This type of stoichiometry problem that I'm going to work here is going to invoke a couple of different ideas. One will be limiting reactants, theoretical yield, and finally percent yield. And this problem has an interesting little twist at the very end that allows us to figure out some information about the material. And so let's take a look. First of all, let's write down what the problem is first. First we have lithium reacting with nitrogen, and they react to produce lithium nitride. First thing I want to do is to write a balanced chemical equation. So to do that, I start off with lithium, and it reacts with nitrogen, which is a diatomic, and it produces lithium nitride. Now what I need to do is balance this. Notice that I have two nitrogens. Here I have one, so I'm going to multiply that by 2 for Li3N, and that gives me 6 lithiums, which then I have to put a 6 in front here. Of course that one stays as 1, so my coefficients are 6, 1, and 2. Now, the second question is, if 5.00 grams of each reactant undergoes a reaction with a 88.5% yield, how many grams of Li3N are obtained from the reaction? Now, to solve this problem, it's saying that I have 5.00 grams of each reactant. And so 5.00 grams of lithium and 5.00 grams of nitrogen. And so in order for us to figure out how many grams of lithium nitride, I have to first figure out what's my limiting reactant. And so to figure out my limiting reactant, I have to convert each one of these grams of reactant into moles of the product in question. And so for every 1 mole of lithium, I have 6.93 grams, and of course from the balanced chemical equation, when I compare the moles of lithium, which are 6, to the moles of Li3N, I end up with a 2 to 6 ratio, and when I go through the number crunching, I get 0.241 moles of lithium nitride. When I do the same thing with nitrogen, I have 5.00 grams of nitrogen for every 1 mole. Of course, there's 28.02 grams of nitrogen in the molar mass. Then from my balanced chemical equation, my mole ratio of 2 moles of Li3N to 1 mole of N2 gives me 0.357 moles. Now, the question is, which is the correct amount? Well, remember that limiting reactant is going to be the substance that produces the least amount of product. And so here the lithium is going to be the limiting reactant. So since that's the case, And I take the value for the moles of lithium nitride. Take that one further step. So 0.241 moles of lithium nitride times its molar mass of 34.80 grams for every 1 mole of lithium nitride produce 8.39 grams of lithium nitride. And that is our theoretical yield. Now, in order for us to figure out how many grams of Li3N there actually are, I have to take advantage of the fact that I have a very helpful equation that the percent yield for this reaction, of course, is going to be the experimental value over the theoretical value times 100. Now the problem is telling us that we have an 88.5% yield, and experimentally we don't know what we have. We don't know what to expect. But theoretically, we're supposed to get 8.39 grams. That, of course, times 100. Now, taking this and simplifying it gives us an experimental yield of 7.42 grams. That is our experimental yield based on the fact that we have an 88.5% yield for this reaction.